there's ever been a more exciting time in technology than today.
It's expanding faster than it's ever been before.
GIS today is more important than ever. It's very exciting because we're in the field. We work with customers, we see what the trends are. The latest trends, of course, has been generative AI. You just talk to your data in natural language. Rather than you knowing exactly what the data schema is and what the data contains and what the map looks like, well, now you just talk to it and the results show up on the map. Taking advantage of large language model to translate text into geospatial analytics is what everybody is excited about.
I definitely see more organizations will be implementing digital twins to support their day-to-day work. So a digital twin is a virtual representation of the real world, but it not only includes physical objects, but also behavior, relationships, and processes. Location is a key integrator for building a digital twin. Everything has a location, so we are integrating different systems and data sources through location to build that common operating view.
I think the biggest trend we're seeing at the moment is an increasing focus on designing and building well-architected systems. A well-architected system is one that's designed to meet the needs of the business, ensuring that the GIS system is built with a solid foundation that can grow and evolve as the organization's needs evolve. A big part of well-architected systems is integration, ensuring that it's connecting to the data and other systems needed to drive those integrated workflows for that organization.
GIS allows organizations to have both a bigger picture and a more complete picture of what's going on today. We're really excited about real-time analytics with our users. That can be supply chain information, facility information, weather events, news feeds, and other data that will help a company and organization understand the real-time information and make timely decisions. We're seeing analytics becoming more sophisticated. We're able to actually do scenario planning and help businesses understand where are their resources going to be impacted.
What I see is taking advantage of the more powerful aspects of GIS for greater benefit for government and city services. Cities are like an ecosystem where there's all these interdependent departments. Everything is interconnected. A good example is in New York City, after an emergency, it's a multi-agency collaborative effort using GIS. The Department of Buildings runs the program, and they rely on their partners like New York City Emergency Management, FDNY, NYPD to handle different aspects of the response. So one person might handle distributing blankets, another may handle finding people a new temporary shelter. There's a lot of great data sharing on the back end using GIS to make it seamless.
There's a lot of possibilities in the work that all of our users are doing.
There's something new to learn every day. We're always finding new opportunities.
I'm optimistic for the future, yes.
The best is yet to come. Yeah, seriously, the best is yet to come.
Welcome back, folks. I hope you had a good chance to connect with some familiar faces, maybe some new faces out in the foyer there. So as you heard in the video, Mansour said the best is yet to come. So team, no pressure, okay? As we come into this part of the plenary, we're going to move into the demonstrations. We want to take some time to show you the applications that you use every day, but the latest enhancements, the latest features, and some workflows and some real data with some real customers that hopefully you can relate to. As we heard before the break, ArcGIS is becoming a geospatial AI platform. There is also, as we said, we're going to cover more and more of this as we go through the conference. There's some dedicated AI sessions. But we want to make it clear that for the AI journey that every organization is on, it's about choosing to use AI in the context of ArcGIS. So if you choose to use AI, then there's a whole bunch of benefits you can accrue in terms of geospatial AI, in terms of assistive AI, and frameworks. So it's a rapidly evolving space, and to tell us more about this, we want to pass across to the team to share some of the latest enhancements across ArcGIS. To show us this, I want to pass across to Edward, to Bianca, and to Matt.
Thanks, Scott. We've heard a lot about AI. Now, let's look at some AI. ArcGIS continues to lead in integrating diverse image modality with AI. Now, join me to inspect one of Network Waitaki electrical substation in Pukuri, north of Otago. Drones are commonly used to capture valuable data such as point clouds, meshes, and oriented imagery. With ArcGIS Pro, you can now use AI to turn pixel into decision-ready layers, finding objects like heat structure transformers or triangular cones. These powerful capabilities streamline the process by automatically projecting the detected objects onto the maps from oriented imagery. And this streamlines and speed up your inspections and reduce the manual work that is required. Our GeoAI toolsets also now support seamless connections to your privately hosted AI services. Using vision language model as an interface, we'll be able to provide scenario-specific context to a generalized LLMs. And we can use this to do image analysis. Here we're looking at post-Cyclone Gabrielle flood zone, and we want to do impact assessment. These models go beyond just simple classifications. It will provide you interpretable reasonings at a grid-level explanations for each of your assessment. We can also do it for larger areas. And this can enhance the transparency and help us to bring confidence in the results. Using just this machine, my laptop can process such a big areas because this workflow relies on bandwidth and not on your local computational powers. Looking at another examples, this LLM-supported GeoAI workflows offers exceptional flexibilities across a wide range of applications, from disaster management down to urban plannings. Here we're looking at doing classifications for a predefined object size, for parcels and its land types. We're not predicting, we are not just doing analysis, we're trying to do reasoning with it. We're combining spatial data with contextual understanding. And now you can see that the models, it's telling us that this is a dealership, a retail lot activities, and not a parking lot. Why is that? It's actually because of the car arrangement. They are parked neatly together, and it's not likely this is a parking lot. With this, we'll be able to deliver insights that are both actionable and explainable. And this is the power of verbal explainabilities. Extending on this topic, we want to look at visual explainabilities. For a really long time, we've been trying to teach machines to see the world as we do. And now with techniques like GradCam, we'll be able to better understand, to learn how deep learning models interpret visual data. GradCams, it will highlight the areas of an image that most influence the model decisions. Here it's saying it's damage. Now looking at the attachments, notice how the image highlighted the collapsed roof section, the debris. And this transparency helps us to build trust. It can speed up triage and also help us to find the catch errors when a model is focusing on the wrong cue. We're not doing predictions. We are reasoning with it. We're explaining what we are looking at. And to tell us more about how AI can help in conservation space, I'll pass it on to Bianca.
By anchoring in a harbour that's been contaminated with the invasive Kalupa seaweed, boaties run risk of spreading it to the next harbour that they anchor in. This map, provided by Ethos Environmental, shows the locations of permanent moorings off the Great Barrier Island where boats can tie up to prevent cross-contamination. To ensure that we don't have any visiting boats on an anchor, I plan to develop a deep learning model that analyzes daily drone imagery. I'm using the Label Objects tool from the Imagery Deep Learning Toolbox and the Auto Detect feature to effortlessly label my examples. But you might wonder what comes after this step. Model Builder now includes an AI Suggest tool feature built to streamline your workflows. Based on a sequence prediction model, it's able to recommend the next logical tool based on your current process, even if you don't know what that may be. So for example, after I've exported my training data, it suggests to use the Train Deep Learning Model tool. With one click, we can add it to our workflow, ensuring that the right tool is always at our fingertips. ArcGIS Pro also now includes an AI assistant, built to boost productivity by answering questions, graphing queries, querying layers, and actioning user requests. Here, I'll be working with Auckland land parcels, regional councils, and regional rivers, all stored in a Postgres database to run a quick flood analysis on Auckland. First, I've used the query layer feature to connect to my database and select all rivers with a stream order greater than 4 in Auckland. Next, I use the action tool to run a 1 kilometre buffer on these selected rivers to produce our flood zones. Finally, I requested for another action to find any land parcels that intersect with these buffers. Thanks to ArcGIS Pro AI Assistant, we've been able to deliver a fast, accurate, and flawlessly executed flood analysis. Now we've seen how AI can be used in the office, but what about in the field? Regardless of whether a severe weather event occurs, damaged utility infrastructure requires fast and accurate reporting. And that's where the new Survey123 Smart Analysis tool steps in. While this form includes a few fields, all I need to do is select an image of the issue. Within seconds, AI-powered image analysis completes the form for us and will trigger relevant groups, such as alerts, if needed. But we didn't stop there. The new voice-to-text feature extends AI-powered analysis beyond just images, allowing anyone to contribute to reporting regardless of typing or language barriers. A field worker may want to say,
挖掘活动导致的水管爆裂影响了附近房屋的供水系统。
AI not only ensures that diverse voices are heard in the field by instantly transcribing and translating the input from Chinese, but it also neatly summarizes the information for us. Now, before I submit, I'm still going to check that I'm satisfied with everything in the form, and if needed, I can make edits. So I actually just want to write that nearby houses have been without water for 3 hours. Survey123 AI analysis tools aren't just smart. They're efficient, they're inclusive, and they're built to support any field scenario. Now, I'll pass on to Matt to show us how we can use assistive AI with a configured web map.
The Data Explorer Internet template uses a natural language AI model to support your analysis and increase efficiency. I will now prompt the Data Explorer to find how many wells are in Ashburton, their use types, and the average depth. As let's say we're evaluating well maintenance operations in Ashburton. Firstly, Data Explorer will come up with a search plan. Next, it will find the appropriate feature layer based on keywords in the prompt. In our case, this is Wells and Ashburton. Secondly, it will come up with a query plan and filter the data set based off this query. We can now see that it has filtered the data set to only show wells with a location field of Ashburton. Now, we can start to see the variety of use types with a built-in UI tabular structure to help your analysis. Finally, shortly we will see that there is over 2,000 wells in Ashburton and the average depth. This information has helped us gain an understanding of the well distributions in Ashburton, which can support future maintenance operations in the area. We have also highlighted how assistive AI is coming to help your workflows and complex analysis. We have been looking at assistive AI. Now let's move on to GeoAI and WebGIS. ArcGIS Excalibur is a web app for analyzing and exploiting imagery. It has come to ArcGIS Online. We are now going to explore how deep learning in ArcGIS Excalibur can be used to streamline imagery analysis and allow for easy collaboration with other team members. Firstly, let's create a new project through the layer search interface. Nelson has some of the highest potential for solar energy generation in the country. Understanding the current distribution of private solar energy adoption is crucial for both the public and private sectors. Here, we can select the New Zealand Solar Panel Detection Deep Learning Package sourced from the ArcGIS Living Atlas. Now let's set our parameters and area of interest. After the model is run, the results will be displayed in Excalibur's map pane and can be easily shared to your portal so the relevant people can access it. We can now leverage our detected solar panels in combination with additional layers and techniques, such as potential solar radiation modeling and solar panel hotspots, to identify areas with potential demand for more solar infrastructure and estimate the total daily power output of existing installations. Edward will now show an example of AI in the web.
iNaturalist is a global citizen science platform where it allows you to record and share your species sightings. To date, there are nearly 28 million of observations that are contributed. Often when you are exploring a dense geospatial dataset like this, it usually will have a hidden patterns or patterns that are emphasized based on the tools or algorithm that were used to create it. We've built a custom web apps using Map SDK for JavaScript that deeply integrate with GenAIs to help overcome this by combining AIs and our users' mapping workflow. At a regional scale, we'll be able to use existing arcade expressions to quickly summarize the common taxon category that are observed in these areas. Now, zooming into Akaroa, we'll be able to link LLMs to individual records. And here, we can explore the data by asking, is this fish a pest? It will perform an intelligent search and confirm with us, no, it's not, and this is the citations. Moving closer, I will click on the next record. This time it's a dolphin. And now I'm curious, is this an species? Now, the LM is telling me, yes, Hector dolphins, apparently it is considered an endangered species, and this is the reliable local data source. Clicking on it, it directs me to DOC's Department of Conservation, and scrolling down, I can see that the conservation status is indeed nationally vulnerable. Moving closer to the Halox Bay, we can also look at frequency and proximities of the data. Here, we can look at doing on-the-fly analysis with the southern fur seal. I'm trying to ask how many similar observations are within 300 meters. With pre-compiled statistic from arcade expression, we know that there are 2 observations within 100 meters and around 80 observations within 500. So the number 55 within 300 meters looks valid. Now I want to show info that are within 100 meters. The LLMs will be able to return 2 records to us, but the information is overwhelming. But thanks to its contextual-aware understandings, we'll be able to filter it further, and this time I will use audios to have a different experience. Show only users and date-related information. Now, we know that Dan's contributed to these records around 2017. With these flexibilities, we can go from regional summary down to extracting insight from individual records. GenAI is transforming how we interact with geospatial data, and now we're using AIs to offer location intelligence in a more approachable, accessible, and actionable fashions. This is how we are using AI. How would you use it? With that, I'll pass it back to you, Scott.
Thank you very much. Thanks very much to Edward, Bianca, and Matt. Just want to point out that Bianca and Mark may be faces you haven't seen before. That's because they're just recent arrivals in the Eagle graduate program. So they did particularly well, I think, presenting in front of a very scary audience like you guys. So a big round of applause for Bianca and Matt especially. So AI, as we heard, opens up lots of opportunities for us. There's a session which will follow on Wednesday, talking at a high level about why the benefits of AI, and then followed on from that, a deeper dive. We'd recommend that if you're interested in this topic, do attend that session. It's a plenary session again, so you're all able to go, there's no conflicts. But we'll cover in that session some of the trust aspects of AI, how you can work with your business, how you can work with your info people internally in IT, to allow you to have the trust in technology, which is rapidly evolving like AI. So please, if you do want to learn more, attend that session in particular. As we heard before the break, the Living Atlas and content from ArcGIS is a fundamental aspect of almost all the work we do. Whether it's base maps or models or layers, it's an amazingly rich source of information that we can draw upon as the basis for our own work. We're particularly lucky in New Zealand with the inclusion of open source data sets under Creative Commons licensing from our national mapping agency, LINZ, from Statistics New Zealand, from NZEUC25, from many, many others. I think we're well ahead of the game in terms of making most of that Creative Commons data. But it's a rapidly evolving space, and you as users are a key in the driving seat in terms of identifying what the future for that holds, identifying what data sets should be in it in the future, what's missing, and also giving us feedback. To give us an update on terms of what's happening in the content space more widely, including some of the new features, enhancements, way beyond base maps and into apps, I want to pass across to Boudewijn and Shanri.
Thank you, Scott. Yeah, today we would like to show you how you can use ArcGIS Living Atlas to help better understand urban heat islands. And urban heat islands are parts of the city that are significantly warmer than the rural surrounding areas. And this is a global challenge, and here in New Zealand and in Christchurch, this is becoming an increasing concern. And these hotter areas don't affect everyone equally. They have the greatest impact on the most vulnerable in our communities. Trees can bring many benefits, as we heard before, and one of them is their cooling effect on our environment. Here in Christchurch, that's recognized through the Urban Forest Plan, which aims to grow and protect the tree canopy. And with climate change, tackling the urban heat island effect only becomes more important. So this climate projections app from the Ministry for the Environment allows us to explore the effects of global climate change. And here in Christchurch, we can see that at the middle scenario, for 2060, we're looking at more hot days. Let's go back to Christchurch. So we can select a scenario and a time frame. And then when it loads, we can see that we actually get 16 more hot days in 2060. Give it one last try and see some color coming back into the map. Because if we look at the worst case scenario for 2100, then we can see that this number actually goes up. So we're looking at 43 more hot days here in Christchurch. But let's move from projections into reality and look at Christchurch last summer. And I want to do that using the Landsat Surface Explorer. So this is one of the many Explorer apps that are designed to look at our planet using multispectral data. And here we can select historical scenes from the full catalog of Landsat. And we can then use a slider to highlight the different temperatures in that scene. So the same Landsat layer that powers this app is also available in Living Atlas. And we can then use it in our map viewer for further analysis.
You can use the full Landsat catalog to explore and select any images through the Image Collection Explorer and add it as a new layer to your map. There are so many predefined visualization templates available. These use different band combinations to visualize things like vegetation, moisture, and in this case, the surface temperature in Celsius. This Landsat Level 2 image layer is not only useful for visualization, but can be also used for analysis. A limitation was the analysis extent was restricted, which made it difficult to process large area. But Esri has optimized this layer as well as the Sentinel-1 and Sentinel-2. So you can easily run it on the large area now in ArcGIS Online. For this analysis, we use the raster function templates that can be found in ArcGIS Living Atlas. So you can easily run it on your area of interest and on your preferred time extent. And you can even add it for your own use as well. We often see Landsat imagery with cloud cover. So the first step is to create cloud-free images from a stack of Landsat images and extract the band that we need for our urban heat island analysis. Next, we calculate the mean temperature over its vegetated area to establish a baseline temperature. To do this, we use NDVI, a band combination that identifies vegetation. The final step is to calculate the surface heat index by subtracting the mean vegetated temperature from the surface temperature. All of these raster functions run as tools in ArcGIS Online. This took around 15 minutes for the whole Christchurch area. Now, we have our surface heat index for Christchurch from last summer, and I have summarized the index within Higgs bands, which not only make the map visually engaging, but also provides a flexible structure for adding other variables later on. We can also use Living Atlas to explore the factors that cause and reduce the urban heat island effect. We can do this through analyzing the land cover in Christchurch.
And this land cover layer is derived from Sentinel-2, and it has data from 2017 till now. So we can use this app to explore changes in land cover. For example, focusing on the built-up area, and we can see here in Rolleston the urbanization happening. We can also look at changes over time using graphs. However, for our analysis, this land cover layer isn't quite detailed enough because we're looking for vegetation inside of the cities. So instead, what we did is we used the land cover classification deep learning package that is available in Living Atlas. It is trained on New Zealand data, so it performs really well here in Christchurch. But to run this on, we need imagery. And that, in the last few years, has become a lot easier. So here in ArcGIS Pro, I can connect to Linz's AWS S3 storage. And there's close to 600 imagery datasets available in there. And that includes a lot of historic aerial imagery datasets as well. Here, for example, we're looking at the same area of Rolleston. And we can clearly see the urbanization that was picked up by the land cover layer. We can zoom in, and all of the data is being streamed directly from S3 into our map. But for our analysis, I pulled in the latest urban imagery from Christchurch. And I added it to a Mosaic dataset and then ran the land cover classification over it. And the results are pretty good, but I want to explore this a little bit further. So I've published this to ArcGIS Online, and then using some blending techniques, we can start to explore the different land cover types. So here we see that same layer again. And tree canopy cover is really important, as in it provides cooling, partly because of the shade. And we can see that that land cover type is picked up really cleanly. But all vegetation has a cooling effect. And that's what is highlighted here. So the hard surfaces, they tend to retain the heat. So here we see the land cover picking up things like roads, buildings, driveways that can contribute to the urban heat island effect. And an interesting way to visualize it is summarize it all in the Linz parcels, for example. We can clearly see that here in the CBD of Christchurch, there's a lot of hard surfaces and a lack of tree canopy cover. And we can identify any parcel here and look at the distribution between vegetation and hard surfaces. We can actually do that as well for just road parcels. And if we combine that with the cycleways from Christchurch City Council, we can start to identify some of the cycleways that have better tree canopy cover and some that have less. And I can tell you that in the midst of summer, it can be quite nice to have a little bit of tree canopy cover when you're riding your bike. But back to our analysis about urban heat islands. So all of those land cover types, I summarized them into the same hex bins that we saw before. And here we can see it visualized on the tree canopy cover. And using this, we now have all the effects, all the causes of urban heat island. But now we can start looking at the impacts on the community. For example, by looking where the most vulnerable in our communities live.
This app has a collection of policy maps that we can create it using the Census 2023 layer from Stats New Zealand in Living Atlas. One of the maps look at the age group 65 years and over, as people in this group tend to be more vulnerable in heat waves. In the map viewer, we can show it too. In ArcGIS Online, we find the rest home layer from Ministry of Health. This layer would be a great candidate as a Living Atlas layer, as it would make this authoritative layer easier to find. As we can see, the rest home layer are located in the areas with higher numbers of vulnerable groups. Using the Enrich Layer tool, we can easily add a selection of the vulnerable groups. And by bringing all the information together in our Higgs-bin layer, we can create a heat risk index. This shows where the community are most affected by extreme heat. The index doesn't just measure the temperature, it also reflects how the heat interacts with land cover and with vulnerable population by using the Calculate Composite Index tool in ArcGIS Online. The heat risk index can help pinpoint the neighborhoods where the additional tree planting or green space would have a greatest impact. It can also guide conversation about urban design, cooling infrastructure, and community support during heat waves. Now, we have our results, and we can start thinking about the ways to communicate this with our audience. One of them could be to create an exploration app in 3D.
I've added the results of our analysis layer to a 3D experience builder, because using 3D it sometimes can help us understand the area that we're talking about a little bit better. But I started by adding a few 2D layers. So the first is the rest homes layer that we saw before. The other one is the early childhood education services from Living Atlas. And this is because quite a lot of our young ones are usually in those areas during the day. What I've done as well is look at the physical environment, and in this case, the trees. So from Christchurch City Council, there's an open tree data set. Using the values for height and crown width, we can visualize it in 3D. And it looks like there's a bit of a gap of tree canopy cover around here. However, this catches mainly the public trees. So we can add to that by using the trees that we have derived from the LiDAR and visualize them in the map as well. From that same LiDAR that is publicly available, we also added the buildings. In this case, I've added the roof color to it from the imagery base map because the roof color can actually contribute to urban heat islands as well. And this app can be used for exploration as well. So we can click on any of these hex bins, and we can see the heat risk index with the variables. But we can also take it a step further, and we can analyze this area using the census data from Stats New Zealand, using the infographics available here. And that gives us a better perspective of the community that lives in these areas. So by using Living Atlas layers, tools, and the deep learning packages, and combining that with the open data that is available in New Zealand, for example, the imagery and the elevation, we can run these complete workflows now in ArcGIS Online. And this helps us to build insightful applications, and that supports decision-making about our environment. And with that, I want to hand it back to you, Scott.
Thanks very much, Boudewijn and Jean-Ray. So hopefully you saw some aspects of Living Atlas that perhaps you're not familiar with alongside base maps. There's some really amazing applications baked into there. So just to recap a few things there, Living Atlas comprises layers, analysis, and also apps. You saw those amazing satellite imagery analysis apps there. We've worked hard to get the Census 2023 information in there, thanks to Statistics New Zealand, as well as things like urban heat island analysis we showed. It's available and you can access this through the app, through the map viewer, through Experience Builder and Story Maps. And we want to call out the open data from some of the organizations who've made the effort to submit their stuff and have it available through the Living Atlas, including MFE, Christchurch City Council, Land Information New Zealand, and Ministry of Health. So thanks to all those organizations. One of the key things about a GIS is it supports workflows. It's not about using just one app all the time, it's about how those apps connect together. And one thing we're particularly proud about with ArcGIS is those apps work well together, whether you're in the field, in the office, or in a web browser. Maintaining the data sets that you have in your organization is arguably one of the most important tasks you can use those apps for. The layers of data that sit on top of the ones which perhaps come from Living Atlas as base maps. Managing that data in the field, in the web, and so on is a vitally important task that many of you spend a lot of time doing right now. We wanted to show an example of how that data can be maintained using that suite of apps, specifically for a local data set in this city. So to show us how these data sets can work, these applications can work together to manage your most important asset, your data, I'm going to pass across to Carol and to Mia.
Thanks, Scott. From the Rakaia to the Waimakariri, Banks Peninsula to Arthur's Pass, Orion's electricity network powers over 228,000 homes and businesses across Canterbury. Behind the vast infrastructure lies an equally complex web of data in which managing and maintaining is no small feat. And that's where utility networks come in. They allow us to model every component of the network from substations to service lines, with real-world behavior built in. Thanks to Orion for sharing their data with us, which lets us showcase how these capabilities come to life. The first step to accessing these capabilities is good data management, necessary not just for utility networks, but for all your data sets. Spotting and fixing errors keeps everything running smoothly. And thanks to the new Vertices and Nodes tool, we can now see how features are constructed and identify errors that aren't immediately visible. We can customize the Vertices and Nodes tool to highlight the nodes that we'd like to see the most. Today, I'm highlighting dangles. This is the endpoint of a line that is not connected to a point feature. And now I can quickly edit my line and resolve that error. Now we'll move into Web Editor, which is bringing advanced editing components into the web. Today, we're looking into a new service extension out in Hallswell, Christchurch, and adding some new connections to that nearby utility network. To start our mapping, I'll first enable snapping so we can easily snap to those existing features. And now, from Enterprise 11.3 and in the most recent release of ArcGIS Online, we can bring in group and preset editing templates to Web Editor. To start, I'm going to use a preset template to bring in a new fuse box. Preset templates bring in predefined features in the exact same way you created them. And don't worry, this fuse box is not to scale. To create the underground line to connect to our new residential extension, I'll snap to my fuse box. And because this is a group template, it creates a new service location at the end. Now that I've added in my new features, I can quickly edit all three of my service locations by batch attribute editing them to change from in-service to proposed. Now that I've edited our data in the office, removed errors in ArcGIS Pro, and added our new proposed features using group and preset editing templates, let's take this critical data into the field with Carol.
Fieldwork is important for commissioning, and field apps make sure crews have everything they need in real time, from receiving tasks to sending updates back to the office. After Mia added the new proposed service extension in the web editor, I opened this Instant App Manager template configured for task dispatching. Using a feature template, I can quickly create and draw a new unassigned task. In the smart form, I define the task type, priority level, and other key details. Values such as the task ID can be automated using arcade expression or integrated with your work order management system. Now, if I need to update several tasks at once, I can also batch edit attributes here. With location sharing enabled, I can see the online field workers and spot who is the closest to these unassigned tasks. Now, by selecting both, I can assign to the nearest field crew in one step. Now, let's switch to the field. On a mobile device, the worker opens field maps and sees the same map. But this time, notice the new and highly anticipated task feature, bringing a clear to-do list experience directly inside field maps. Tasks can be organized by different values, such as their priority level, so the critical ones stand out. The worker opens the task and can immediately get to work. First, I will need to upload the photo of the new asset. Moving on to the next step, the task guides me to update the new asset details. With Edit Multiple, I can select all the new devices and update them at once, changing their lifecycle status from proposed to in service and setting the date. Once updated, I can run a trace. Run a trace to verify their connectivity back to the substation. And notice this whole workflow works with an offline map, meaning I can perform tasks, data editing, and tracing without a connection. Now let's finish my commission service. But if I spot an additional issue, like overgrown vegetation, and I don't have the right tools to deal with it on the spot, I can report it to Microsoft Teams. So my team is notified right away if a new task is needed to be created. Oops. There we go. Now let's switch back to the office again. Our utility network runs across New Zealand, but damage to underground assets can be costly for utility owners, the public, and those who cause it. With local maps, we can request underground information before digging. For instance, when I click on this requested area, notice the report icon in the pop-up. That means reporting has been set up. From here, I will select the digging utility report and hit submit. Imagine the request is processed and the report is downloaded. Here's the PDF. It combines text, maps, tables, and data from multiple sources, like Orion's electricity network, Christchurch City Council's Three Waters data, and LINS. Some data comes directly from the Living Atlas, so we're combining public authoritative data with private asset data. All in one place, local maps makes it simple to access the information needed for safety and damage prevention. So those are the new enhancements to editing and data management across the ArcGIS system. The best part is that many of these tools are shared web components. So whether you're a map viewer, experience builder, field maps, or any other ArcGIS apps, there's a good chance you can perform the same workflows in a consistent way. Thank you.
Well done. Well done, team. Thanks so much for that. Thanks for being with us. We had a dodgy cable there with the old iPad, but hopefully it gives you a sense of how those applications fit together. So a quick summary of what we saw there. We saw ArcGIS Pro being used to edit and prepare the data alongside the very powerful web editor. That being brought together with instant apps, specifically around the area of task management. And I think that's an area that will be a lot of interest to many of you, using the GIS to actually manage and assign tasks for those going out into the field, seeing those tasks turn up inside of field maps, And then finally, bringing it all together in terms of the data sets that are our own data sets and also Living Atlas data sets to create that packaged report as a PDF with some conditional logic and some nice formatting. So thanks again to the team for bringing that together for us. And thanks again to Orion for sharing their data. It was really cool working with them. So one area that I believe takes GIS well beyond mapping is the area of analytics. Being able to ask questions of the data sets that sit within our databases, within our maps, to use the power of computing is an area that we're very excited about and which is also evolving very rapidly. With the addition of powerful algorithms, lots of compute, and also with lots and lots of data, this area of analytics is really rapidly changing, whether it's raster or vector. With this rapidly changing area, we've got new opportunities to do things like predictive analytics, seeing the future, which is not something we've typically been able to do in GIS very readily. But now those tools are baked into ArcGIS and we can use them in our own workflows. To talk a bit about how spatial analytics is being used in a variety of different applications and some key workflows, I want to pass across to Jess and to Fran.
To begin our story, this is an ArcGIS dashboard and map built by SBS Biota. SBS Biota is one of New Zealand's leading providers of biosecurity services. Their team has inspected thousands of trees across Auckland, identifying cases of Dutch elm disease, a fungal infection spread by bark beetles. They've also tracked whether or not their trees have been injected with a vaccine, but also monitored beetle trap sites to track how the disease spreads. Their work has been vital in helping Auckland Council respond quickly to outbreaks, and this map gives us a historic overview of the work that they've done. But in future workflows, SBS Biota might need to anticipate what happens next. How soon will the next tree become infected and die? So let's take a look at these same data sets and test some potential hypotheses with our desktop analysis tools in ArcGIS Pro.
Here we have tree points across the Auckland region. And using the brand new Estimate Time to Event tool, just released in 3.5, we can do some predictive analysis for when death from infection might occur based on a set of input parameters. In this case, we've included the distance to the nearest positive beetle trap, whether the tree ever had a vaccine, and its current health condition. And in ArcGIS Pro 3.5, we want to highlight that tools that support the memory workspace, like this one, will show a button next to the output parameters. Clicking it sets the output to memory, which is ideal for temporary data and faster performance. But in this case, we want to keep our outputs as permanent. The result gives us median time to event and percentiles showing a range of possible times. This layer lets us see when and where trees are a higher risk. And here we can highlight which trees are at higher risk of dying within the next 70 years. We've generated a 3D scene, aggregated our trees into bins, and extruded by amount to help us visualize our results. And we can immediately see that this bin stands out as it has a lot of trees at risk. This kind of insight helps us prioritize inspections, plan interventions, and allocate resources more effectively. Now, moving away from the desktop and onto the web, we're excited to announce that ArcGIS Business Analyst web app is now available to all creator and above user types. This application is a prepackaged solution that combines data, tools, analysis workflows, and an intuitive user interface, where you can perform analysis using demographic, socioeconomic, and your own data, all without needing advanced GIS skills. It also now includes all the capabilities of community analyst, making it even more powerful for public sector and community-focused decision-making. So let's see how this web application can help us explore vulnerability in Christchurch. We'll start by making sure that the data source is set to New Zealand, so we can start exploring the more than 700 available variables. Now, we'll create a color-coded map. We'll choose Christchurch as our area of interest, and then choose our desired level of detail. Now we can start browsing through the variables. For our analysis, we chose total personal income and disability indicator. And after seeing the results plotted on the map, we can immediately see a pattern. The lighter color represents lower income, and the bigger circles show a higher percentage of disability in the area. So areas with higher rates of disability tend to have lower income, which we can see represented in the summary graph as well. This spatial relationship helps us identify communities that may face compounded challenges. But to better understand who lives in these areas, I'll click on one of the vulnerable zones and generate an infographic. These are visually engaging summaries with key statistics about a location. You can create your own or select one of the pre-configured templates. I'll choose Community Profile. From here, we can see that this area has a higher proportion of senior citizens, which adds another layer of vulnerability. For this analysis, we've used available variables, but if we wanted to add more context to this, with Business Analyst Advanced licensing, we can also start bringing in our own data. Here, I've added a spreadsheet with council service requests submitted by residents, so we can easily start integrating it with our demographic insights. And in Business Analyst Web App, you can also perform various analyses, like threshold areas, void and suitability analysis, and the newest benchmark comparisons. With this tool, you can select the sites you want to compare, select the variables, and choose a record or a statistic as a benchmark, so you can see how the rest of the data compares to it. Here we're comparing different constituencies against the average for our key vulnerability indicators. This can help us see which areas stand out and where support might be most needed. And from here, you can share your results across your organization or other ArcGIS Online applications, like this experience, which leverages the Business Analyst widget. But you can also export your benchmark results to Microsoft Excel for further analysis. There are so many great tools to explore and work with. And remember, everyone at the creator, user type, and above now has access to this application.
So we've just seen how business analysts can generate really powerful reports in Excel. Microsoft Excel is one of the most widely used analysis tools in the world. So what if we could go further and we could bring spatial science into Excel itself? So we're starting here with a sheet of Metlink bus stops, which is hosted by Greater Wellington Regional Council. Metlink are in charge of the transportation network across the Wellington region. Now with the function builder, we have access to all these different geospatial calculations. For instance, in this column, I can run the function enrich by point, use my longitude column, my latitude column, and a variable from the New Zealand census, like total personal income. I'll set my distance and click update, and almost instantly get a new demographic value that's been calculated, and I can drag that down and calculate this for any of my rows. Now, if I return to the map, and I click on this layer, I can save, and that syncs back to ArcGIS Online. So here, if I go to my Map Data tab, I click on my first bus stop, and click on it, I can see that new value in the pop-up already. But sometimes our data lacks coordinates. If I go to my reliability tab here, I have non-spatial bus performance data from Metlink. And I can add this data by using the location type, but I set it to be my own geographic data. And then I can search through ArcGIS Online again. I'll pull up the bus routes this time. And basically I can create a join. And what this means is that I can create a bridge from the bus routes layer here to all the columns in my Excel sheet. So we've enriched, we've styled data in Excel, but let's see how we can bring ArcGIS into Microsoft Power BI reports instead. Like many other organizations, Metlink's Transport Analytics unit has already created really stunning dashboards like this one, which shows the bus route boardings by service. But to truly understand the patterns, we need to see them spatially. In my own version, in a draft, very similar to the one I just showed, we can create an ArcGIS map directly in our Power BI report. And this is connected to my portal account. From here, I'm going to find that bus routes layer once again and add it to my map. But this time, I want to add some of the data from my actual Power BI insights. We have a setting here that's called the join layer. And so I pulled in some fields like the regions and the actual bus routes as well. And then I created a standalone join layer. And what this allows me to do is create a map that can be dynamically filtered, just like the rest of all our insights in Microsoft Power BI. In recent years, we're also seeing larger and more complex data sets than ever before, which means we need more powerful analysis. Microsoft Fabric is a cloud-based unified data platform for organizing, analyzing, and sharing data across tools like Power BI that I just showed, Spark, SQL, and in notebooks like this, we can manage and engineer the same data sites like bus reliability, route locations, but also access a really massive data set of car crashes across New Zealand, stored centrally in one lake. Traditionally, maps have always been pretty useful, even when they're static like this in our geospatial workflows. But with ArcGIS GeoAnalytics engine now being deeply integrated with Microsoft Fabric, we can do a lot more. We ran a spatial temporal join across these data sets, meaning we ran a function that paired our two variables, car crash locations and annual reliability scores, not just spatially, but also on the matching year between the crash event and the year of the score. So as we can see here that in general, as time goes on for each bus route, as car crashes go down, reliability seems to go up. And in this final cell, we end on a map again, but this time it's interactive. And this helps us show the results of our index that we've calculated from that spatial temporal join. So this is the power of integrating analytics everywhere with Microsoft Office, business analyst web app, or desktop software like ArcGIS Pro. Whether it's enriching data, it's visualizing insights, or running really advanced spatial analysis, ArcGIS is there, connecting your data, your maps, your analysis, and your decisions. Thank you.
Excellent. Thank you very much, Fran and Jess. Hopefully you got a sense of how we can integrate with other applications, in this case the Microsoft suite, and how we can extend the capabilities of those tools and bring spatial, not just for visualization, but with those analytics. Also, that initial analysis around the spatial temporal and looking at the predictive aspects, I'm really excited to see how you can use those same tools to analyze and predict the future in your own worlds on desktop, web, and also on the other tools. We're going to take a little break from the demonstrations for a few minutes to go back to the focus of customers. In this case, we want to talk about a particular project that's being run by Fire and Emergency New Zealand. Fire and Emergency New Zealand, or FENZ, have been a powerful user of GIS for many years, including GIS embedding within several key enterprise systems that they have. This includes web GIS workflows and also the heavy use of mobile field apps, just to keep Sarah happy. However, they've recently embarked upon a new project to transform how their firefighters access critical information related to the buildings and sites that they have to access all across New Zealand, including when they're responding to fires. To tell us more about this project, I want to introduce FENZ's Geospatial Products and Analytics Manager, Phil Woods. Phil.
Kia ora, Phil Woods, Tuka Wingoa. For many years, frontline staff at Fire and Emergency New Zealand have created and maintained site reports within the Station Management System, or SMS as we call it. These reports are critical for incident response nationwide. They often include a site plan, which is a map of a specific building or site showing entrances and exits, alarm panels, hazardous materials, and other features that support a rapid and, most importantly, a safe response. It's easy to imagine what arriving at a large industrial site in the middle of the night might be like. You know, you've got crews rolling in, alarms sounding, you've got toxic smoke pouring out from a building. You would clearly benefit from knowing where the hazards are. And where the hydrants are, where the access points are, yet often the only map that we've got is a scanned floor plan with handwritten, scribbled in the margins kind of annotations, or worse, as you'll see. That's unfortunately the reality our people often face at the moment. SMS was introduced in the early 2000s. By any standard, it's dated these days. And like many mission-critical platforms at FENZ, it's deeply embedded into our operations, which makes, transitioning away from it a, pretty challenging task. So at the time, the technology's moved on a lot since then, and although the transition to something more modern and appropriate is underway, it needs to be carefully staged over several years. So geospatial plays a big part in this shift from more consistent and unified building models to new tools for creating site plans and eventually mobile apps for field capture. And with Esri and Eagle, we're starting to explore some of those, powerful new ways of presenting this, critical information to our frontline responders. So we'll go back to the problem here. So the problem, let's start with this, the challenge. We know that to respond effectively to large or complex buildings and sites, we need really good reconnaissance information, but within SMS, little thought was ever given at the time of its development into producing site plans in a kind of a consistent way. So the result after about 20 plus years of this now is that we have thousands of digital maps. No real standardisation has been applied. Some attempts have been made, usually at a regional level, and a few of those have actually stuck. So we've seen a bit of everything. We've had hand-drawn sketches, and you can see some glorious examples behind me. Hand-drawn sketches, annotated building plans, Visio diagrams, things created in Microsoft Paint. And if you've ever tried to draw a straight line in Microsoft Paint, you must know what they look like. Creations, and some of them, works about. Others are creative. Some of them functional at best. The outcome is exactly what you'd expect, a patchwork of maps with wildly different levels of quality and consistency. Some are great, some are okay, as I said, most are just functional. And, from any standard in this room, you wouldn't say that they are cartographically or geospatially robust at all. So what now? What can we do? So we can't fix SMS, as we discussed, that's a big complex beast of a thing, but we can at least address the mapping. After all, site plans are just map documents linked through to SMS records. So our geospatial team built a new standardised site plan creator tool. It replaces the myriad methods in use across FENZ, and it lays the groundwork for moving from static documents to a centralised digital solution, effectively, a GIS that people can use instead of paper maps. To get there, though, we had to overcome some challenges. We needed a robust, highly available enterprise GIS environment. Check, we have that. We needed a schema that was simple enough for firefighters to use, but robust enough for the purposes now, and to have some forward thinking in that as well. We needed to make sure that it was ready for the future. We needed a palette of features based on industry standards. And we needed cartography that meant a site plan in Auckland would look the same as a site plan produced elsewhere, like in Chicago or something. Instantly recognisable, consistent, reliable, fundamentally. And of course, we needed new dynamic map templates to guarantee that consistency across the output. We still need to print these things out and attach them to SMS. SMS later on will get a bit smarter, but in the interim, this is a necessary step. It's a simple idea, but a powerful solution. And my colleague and good friend Rebecca Lutz will be doing a deep dive into its development in her stream session later in the conference, and I definitely encourage you to go and check that out. That'll cover a lot more of the technical kind of ins and outs of how we approach something like this. Where to from here? So right now the tool still feeds into SMS, as I discussed. That progress is really, though, just the beginning. There are kind of two big steps that we can take from here, one in the short term and one taking a longer term view. The first is a mobile application using quick capture. It will enable field staff to go out in the field and actually collect that information. Currently, they take the information on a notepad or something, come back to work, and then they'll sit down at whatever they're using, Microsoft Paint, and they'll start to create their maps, and then they'll attach them to the relevant building. So this will obviously make that a lot easier. And you'll see a demo of that pretty shortly, in sort of practical terms. Second, and probably the biggest one and the most exciting one, and it resonates pretty well here with everything that we've just seen, is a move to 3D. So many of our staff, many of our site plans can be developed into 3D models using straightforward workflows. We don't need cinematic grade, super fancy 3D models. We just need practical use, usable ones that can help firefighters understand a site quickly. For years, 3D has promised more than it's delivered, in my opinion. Overly complex models looked amazing, but weren't practical in the field. But today, with faster computers, more user-friendly platforms, 3D is now probably a lot more approachable and is probably ready to deliver for FENZ as well, particularly as we start to look at things like digital twins. And for our firefighters, being able to virtually walk through a building before stepping inside it, game-changing type of stuff. It builds confidence, shortens decision-making processes, and ultimately it keeps our people safer, which is the key goal here in many ways. And with that, so it's the perfect time to hand over back to Scott and to Zorko, but I'd just like to acknowledge a few people here in this. Firstly, Gert Van Maren. Gert has been absolutely instrumental in putting together, helping us with this strategy, moving from our 2D site plan maps into something 3D, and Zorko is going to show that soon as well. But also the team at Fire and Emergency have been involved in this, and it's covered a lot of bases here. So from subject matter experts through to the development team, so Becca, Craig, Matt, Jazz, Hamish, and they all deserve some credit here. And so with that, I'll hand over to Zorko.
Thanks, Phil. Thank you very much, Phil. So hopefully that gives you a sense of the important work of a GIS tool being applied for a really important mission, which is giving firefighters and others the ability to understand the spaces in which they might be entering, whether it's in 2D or 3D. And as Phil also said, his colleague Rebecca is presenting in the Data Management Aotearoa session, which is tomorrow afternoon. If you want to go and check it out, please encourage you to do that. So building on what Phil said, we thought it would be a good idea to expand on some of the concepts that were covered in his update. Phil mentioned the fact that they're looking at 3D as one of those next steps. And actually, when we had this conversation not so long ago, we connected because we're seeing a huge amount of interest in organisations in New Zealand moving to that next step in 3D. Primarily, there's a lot of interest in the indoor space. So people are wanting to create 3D versions of the indoor spaces in which they work, which they manage, which they own, which they operate, or which they visit. And there's actually been a real absence of data in that space. Unlike outdoors, we've got an amazing living atlas and open data is fantastic. Indoors, there's less data available. So it's been a real challenge for people making that move to that 3D version of their indoor spaces for whatever purpose, including the really important mission that Phil described. So with the barrier of the availability of data, we thought it would be useful to look at some workflows where you can take the data sets that you might have in-house, whether that be MS Paint drawings that Phil spoke about, CAD, etc. Those data sets that you might have in-house, and look at some workflows which we've developed, including the reference to GERT, and how those can be used to create 3D versions of the spaces which might be important to you. So to show us an example of how those workflows happen in real life, I want to pass across to Zorko.
Thank you, Scott. So we saw in Phil's presentation some of the challenges that FENZ is facing, trying to represent the 3D buildings and interiors to the crews in the field. So here's a story map that will tell us some of the workflows and options when we do that. So like I said, FENZ is one of the organizations that is struggling to bring these interiors and the buildings to the crews in a field, but they are not the only type of organization. So there are any type of emergency response teams, also facility managers, even urban planners, and any other organization that has to deal with interior spaces of the 3D buildings. Now, when we talk about 3D buildings, in some or if not more cases, less is more. So we want to make sure that our crews or users can easily comprehend the interior space of the building. And to do that, we need to look at some of the basic information about the interior space. So that will be height of the floors, location of the windows, location of the doors, or any other elements essential to your business. If you're looking at a fire emergency, it will be extinguishers, smoke detectors, or any other key assets. So other organizations that would benefit from these simplified views, I've mentioned the first responders, paramedics, and police, and the reason why they could benefit is simplified view that allows them to quickly observe and determine where are the entry-exit points and where are the key assets within the building or particular floor in question. Now, how do we visualize this 3D data? We're going to show you how you can use it using basic point, lines, and polygons, and attributes are the keys in this example. So if you want to use these point, lines, and polygons, something that we would like to recommend is to look at using ArcGIS indoor schema. This is just for a future proving. And what do we have here is ArcGIS Experience Builder application, which is custom built to show us the floors in both 2D and 3D space, so we can start navigating and having a look at particular floor and assets for that particular floor, again, in order to make it most efficient for the crews. What if we don't have any of this information? What we can do is we can look at the absolute elevation. Here we see example of the arcade script that was actually used to create this model that we saw just previously. And that arcade model is looking at elevation of the ground floor and then looking at height of the floors and the order of floors so we can model above and below the ground. And when we look at all of these, there could be a case that we want to look at these workflows. So I'm going to show you 4 different workflows. How can we use points, lines, and polygons to bring these features into 3D? The first workflow is based on PDFs. Hopefully you all have some sort of PDFs, and the workflow will start with extraction of images for the floor plans, georeferencing them, creating an indoor schema, drawing features on top of these scanned images, and then populating attributes. If you have a number of layers that are required for your assets, it may take a little bit of time to populate all these attributes. When the attributes are populated, we can start looking at these layers in our map viewer and simply using absolute elevation. And you see here how we can display floors, and then you will see the walls and any other features. The second workflow is with using CAD data, and it's similar in steps to our first workflow with the PDFs, starting with georeferencing, creating feature layers in indoor schema for future-proofing, importing floor plans, refining or, if needed, drawing the features, updating of the attributes, and then, as usual, visualizing them in a scene viewer. And if you are lucky, you may have some data available as Revit or IFC files. So the workflow that we see with these is somewhat similar. We may start with georeferencing, which may or may not be required, and then creating scene building layers, adding them into scene viewer, sharing, and then using all the tools that are available within the scene viewer for your everyday use. But what if we don't have any of these available? What we can do is we can use 3D building solution. That solution is freely available, and once deployed, we can use the workflow, like in here, to use the tasks within the workflow to create the shells. After that, we can start creating floors, publish these floors, share them, put them into scene, either in ArcGIS Pro or ArcGIS Online and Enterprise, and start creating our applications. So these applications can be utilized as they are, but that can be also enriched using other applications like Phil mentioned earlier, using quick capture, or even using different data sets like oriented imagery, which we see here in this example of the application. And the data that you have, the 3D data, can be used for different purposes. And some of the purposes that can be used are, for example, facility management, real estate, urban planning, or any other for emergency response. We can also use them for advanced visualization. So here is an example of scene created in Maps SDK for JavaScript, or we can use Maps SDK for game engines. And speaking of Maps SDK for game engines, here is XR Viewer, a brand new application, and I can look at any of the scenes that are available to my organization or group. So here is a scene of Takina, where we had a conference last year. And when the application loads, you will see how it looks. It's designed to operate in virtual reality and the desktop mode. So here we see virtual desktop, just to give you a little bit of context what that looks like. It's ideally viewed with a virtual reality headset on, but we can use it in a desktop. So I'm going to choose a map over here, and that will show me the 2D view, which will be synchronized with my virtual tabletop. And with the virtual tabletop, I can use usual operations to navigate around the scene, zoom in, zoom out, and panning. And what is more interesting is looking from the first-person perspective. So I can use this first-person perspective tool to look at that ground level, how does the scene look like? So we can start navigating around the scene and seeing how that scene compares. XR Viewer also supports collaboration by having multi-user sessions. And to help you with that, what you can utilize are presentations. And here is a presentation, a very simple one, where we can start with our tabletop view to give us a sense of where it is. And then we can drop into our first-person view, and you can bring extra realism to the scene by adding atmospheric effects like thunder, rain, and wind. And this was just a glimpse of XR viewer application coming soon. Over to you, Scott.
Thanks very much, Zorko. So hopefully that gets you excited about the XR viewer and what you can do with 3D. Phil said before that he doesn't need to have that cinematic experience, but sometimes you do. You want to engage people in a very realistic environment. And so the same tools with the same data sets can do that. I have to say, if you've got a chance to get, or everyone's got the chance to be part of the beta program for the new XR app, I encourage you to sign up for it and check it out. But also, if you can use it with a headset, like Zorko said, it's a truly amazing experience. My mind was blown when I first did it and walked around the virtual version of Wellington in a snowstorm, which was very exciting. Okay, so we now want to move on to the final segment of our day, where we're focusing on arguably the most important aspect of all, and that's our community. As technology companies, both Eagle and Esri have been around for over 50 years. And we know that while technology and digital changes every day, the community and the people endure. One specific initiative that we're very proud to be part of is the Esri Young Scholar Programme. For the past 13 years, Eagle has worked with Esri on the Global Young Scholar Programme, selecting one outstanding student each year from each country. The 2025 New Zealand Esri Young Scholar Award was awarded to Hau Verco from the University of Auckland for his outstanding project on the adaptations of marae for natural hazards resilience. The innovative project beautifully integrates Te Ao Māori concepts, engineering expertise, and the power of ArcGIS to tackle real-world challenges facing Māori communities. Hau travelled to San Diego as his prize for this award in July to showcase his project, to meet fellow award winners from other countries, and to network with literally thousands of other spatial professionals. So, well done to Hau. I also want to call out that the judges recognised two significant runners-up in this competition, and those were Amber Halton and Isaac Waterman, both from the University of Canterbury. So please join me in appreciating all their hard work. Alongside the Young Scholar Programme, we wanted to highlight some of the other communities and related initiatives which are integral to our community as a whole. Some are also focused on education, such as the GIS in Schools and Universities programme, with amazing work being done across New Zealand at hundreds of schools and literally thousands of students. The work of these awesome teachers is supported by Eagle, and we're very proud to have Claire Thurlow leading that charge from within our team. Alongside that, in the education space within Eagle, we're very proud to have Gallup as our internal 6-week GIS Academy. Many people in this room and everyone on stage has been through that academy. Both customers and our own staff go through it. So if you're looking to fast-track people into the GIS world, it's a great thing to consider. We run it twice a year. Other communities' initiatives are focused on areas such as conservation, being greatly supported by the GIS and conservation folks, or on emergency management, where GIMA is doing an amazing job of connecting and supporting this community with Eagle's own emergency GIS hub, with ready-to-use resources to help in the back end, helping people to use ArcGIS in emergencies when it really matters. Finally, I want to acknowledge the support of the New Zealand Esri User Group as a very long-term supporter of this event and of the user community as a whole. So I'd now like to invite the New Zealand Esri User Group Chairman, Matt Gross, to come up and share a few updates with you on their role at this conference and beyond. Matt.
Thanks, Scott. Excellent. Amazing to be here up on stage at the plenary. This must be what it feels like to win an Oscar. I'm here to give a shout out for NZEUG and all the things that it does. I've just noticed that I'm up on the screen there. That's quite scary. So let's begin with the who or the what. NZEUG, the New Zealand Esri Users Group, exists to connect, support and empower our GIS community. This is your group, built by the community, for the community, and we'd love for you to get involved. I'd like to pause there and circle back to something that was said earlier on in the plenary. Brian Cross said, New Zealand has the most impressive and impactful user community in the world. Wow, that's pretty good. That's you lot, the user community, impactful. I think that's a bit of a treasure to hold on to. And I don't think that happens by chance. I think an awful lot of effort goes into that from all sorts of organisations. But underneath it, there's Eagle there who make an awful lot of effort, which is often unseen, to create the community and the group hug that we belong to. So, what do? We do a number of things. RUCs, the Regional User Conferences, GIS Day, the Gallup competition, EUG Tube, Spatial Industry Survey. All of these things that we do help folk connect or grow within the industry. At least that's the aim. So let's focus on the big one. Every year, in partnership with Eagle Technology, we deliver the Regional User Conferences. I know what you're thinking. I haven't even done this conference yet. What are you talking about, more conferences? That's fair. In 2025, we had 8 locations, 700 people registered. Dunedin, Hawke's Bay, Nelson, Palmerston North, Hamilton, as well as the big 3. The 2026 year is being planned. I'd like to go to Northland. So if Northland folk are here, can we connect so we can start looking at that opportunity? The RUCs bring technical updates to the local GIS community direct from the Dev Summit. This localness means that there aren't travel and accommodation overheads to deal with, which makes them accessible to more of your team. The localness also is about collating local user stories to share at them. I've always encouraged folk to share unfinished things, problems, stuff that didn't work. Share the pain with your peers. People like sharing. But we do rely on local folk contributing. If you don't contribute a story, there's a risk we end up having to show recorded presentations from Wellington, and nobody wants that. So the onus is on you. Make these events what you want to see by stepping up. When the call for papers goes out, just remember that. The events do cost. 40% of the cost is met by membership subs. If you haven't paid your subs yet, please do so. It really matters. A small dollar cost from a lot of people makes our treasurer very happy. The 700 registered folk, I think, is also a valuable audience for corporates too. The remaining 60% of the cost for these events is met by sponsorship. We will be doing the rounds at conference. That's not really a threat. We will be doing rounds at conference to look for event support, but we're also looking for longer-term partnerships that can support NZEUG throughout the year and allow us to do the work that we do. I mentioned Gallup. Every year, Eagle makes a place available on both of the Gallup intakes, which we provide competitively to the community. Gallup is the best concentrated training available and is an absolute gift to somebody early in their career. If you know someone who would benefit from that package, then watch out on the socials or in our members' newsletter for the next intake. The competition should be live in October. What are you doing at conference, I hear you ask? No, okay, sorry. Good news, more competitions. We have a fun comic-themed competition with a real prize at the end, a copy of Mapmatics, the maths of mapping. I mean, what's not to like? So come and find us at the Community Hub. We'll have some devices set up to do the competition. Have a chat, have some lollies, and while you wait, good times. I think that'll do for me. Thank you very much. Really looking forward to chats and hugs all around. Thank you for this time. Thank you, Scott. I'll pass the baton back up to you.
Thanks, Matt. Thanks very much. Thank you very much, Matt. So yeah, just to reiterate, user group are not just at this conference, they're all year round, but they are at this conference in the Expo. So check them out. Speaking of this conference, this event is brought to you by a team, a very large team, and a key part of that team are our sponsors and our exhibitors. And I want to specifically mention some of those guys right now. Our gold sponsors here for this year are GBS and Seamless, both of whom are important members also of the New Zealand Esri partner community. Alongside these gold partners, we have other partners supporting particular aspects of the event itself. They're joined in the Expo Hall with others. So the Expo Hall is through that door there. You'll be going there very soon. Please do go and visit our exhibitors. They've all got some valuable additions to add, whether it be services, data, applications, or just knowledge and expertise that really sit on top of the work that Esri and Eagle do. So as I said, inside that expo, there's a number of exhibitors. One special corner, this corner just here, is the Community Hub, where every year we invite a number of community organizations to come along and share their stories and connect with you as a community for free. So please do encourage you to go along and to connect with some of those groups, whether it be the emerging spatial professionals, GIS and conservation, survey and spatial, the user group you just heard from Matt, the GMA around the emergency management space, or lifelong learning. But also I'd like to say if there's an organisation that you represent, you think you should be in the community hub in future years, please do come and let us know. That is a growing and really vibrant community. Beyond the expo, on Tuesday night, as you heard from Dwayne, we have the world famous New Zealand Esri User Conference Gala Dinner. It truly is world famous. When we go to the Esri conference overseas, people talk about our conference dinner and they're trying to get there. So we might be selling tickets overseas in the future. So this year, the conference is brought to you by our sponsors, Data Miner. And the year's theme is the relatively open-ended and open to interpretation Comic-Con. So I look forward to seeing all of you guys in your amazing Comic-Con costumes there on the Tuesday night. And it's here in this building in the Rivers Room, which is just upstairs with a beautiful view over the river. So that brings us to the end of this session. I want you to ask you to join me in thanking all of our presenters and our guests, first of all, for the amazing work they've done in bringing the stories to you today. And I also want to thank all of you, not just for coming to this session, but to coming to this event. We recognise that many of you have travelled a long way. We're looking forward to making it worthwhile for you throughout the week. The next immediate thing is we've got the welcome function, which will be held in the expo. So all those exhibitors you were dying to meet, they're dying to meet you next door. So please, I'll see you through next door in the expo room for the welcome function. Thank you again. Have a great conference. Thank you.